Pluto was once known as the ninth planet from the Sun, a fact many of us learned in school. But in 2006, that status was revoked and Pluto was reclassified, seemingly erased from the planetary lineup. Yet, that decision didn't sit well with everyone. A determined team of scientists refused to give up on Pluto, and that same year, NASA launched the New Horizons probe on a groundbreaking mission to explore this distant world up close for the very first time. What they discovered was astonishing. Our previous understanding of Pluto was completely mistaken. The authorities had it wrong, and so did nearly everyone else, because Pluto turned out to be far more complex and intriguing than anyone had imagined. While it may no longer be classified as a planet, it stands as one of the most dynamic and enigmatic locations in our entire solar system. So, why was Pluto demoted in the first place? It wasn't due to a conspiracy, but rather a gradual evolution in how we define and categorize celestial bodies. This process has been ongoing for centuries. In the 1800s, for instance, modern astronomy was just taking off, and at one point there were around 20 recognized planets. Every time a new moon or large asteroid was spotted, it was often labeled a planet. Eventually, scientists realized the need for clearer, stricter criteria to determine what truly qualifies as a planet. This refinement has continued ever since. Astronomers suspected an unknown object was affecting the orbits of Neptune and Uranus. After 10 months of careful observation, Tombaugh detected a faint, slow-moving point of light beyond Neptune. He had discovered what everyone at the time considered a new planet. Back then, the rules for planethood were simpler. First, the object had to orbit the Sun, which is why moons don't count. And second, it needed to be unique in its location, which ruled out asteroids since they exist in clusters. Based on the available data, Pluto seemed to meet both conditions. It appeared to be the only significant object in that distant region. Pluto's downfall came in 2006, when the definition of a planet was updated to include a third requirement. A planet must have enough mass to clear its orbital path of other similarly sized objects. In other words, it must act like a cosmic vacuum cleaner, sweeping up debris as it travels. A true planet must dominate its neighborhood. As it turns out, Pluto isn't traveling through an empty void. It's actually part of a vast collection of objects known as the Kuiper Belt, often described as the solar system's junkyard. This region contains leftover material from the solar system's formation that never coalesced into the Sun, inner planets, or gas giants. Pluto isn't even the largest object in the Kuiper Belt. It's just the brightest, which is why it was spotted first and mistakenly thought to be alone. Interestingly, Pluto is one of the most reflective objects in our solar system. Only Venus and Jupiter have higher reflectivity, mainly due to their dense cloud layers. From a distance, this brightness made Pluto appear larger than it really is. Pluto's orbit is also unusual. It follows a highly elliptical, oval-shaped path that sometimes brings it closer to the Sun than Neptune, nearly matching Uranus's distance. Additionally, Pluto's orbit is tilted about 17 degrees relative to the flat plane where most planets orbit. This means Pluto is usually either above or below us, though we wouldn't notice much since it takes 248 years to complete one orbit around the Sun. Because of these factors, Pluto doesn't meet the current definition of a planet, but its uniqueness makes it incredibly fascinating. That's why engineers at Johns Hopkins University built the New Horizons probe, to uncover just how strange Pluto really is. Coincidentally, NASA launched New Horizons the same year Pluto's status changed. The biggest challenge was the immense distance. To save time, they mounted the relatively lightweight probe, weighing just 1,000 pounds, on the most powerful rocket available at the time, an Atlas V equipped with 5 additional side boosters, generating around 2 million pounds of thrust. New Horizons shot away from Earth at incredible speed, passing the Moon in just 9 hours, about 10 times faster than the Apollo missions. After 1 year in space, the probe approached Jupiter. NASA used this opportunity to test its imaging systems, capturing stunning photos of Jupiter and its moons, including an erupting volcano on Io. But the main reason for flying so close to Jupiter was to use its gravity as a slingshot, boosting the probe's velocity and setting it on a direct path to Pluto. Even with that gravitational assist, the journey through the outer solar system took another 8 years. In 2015, as New Horizons drew near, it began transmitting the first close-up images. 2 bright points of light grew larger day by day: Pluto and its largest moon, Charon. The relationship between Pluto and Charon is peculiar. Charon is about half the size of Pluto and orbits remarkably close, just under 20,000 kilometers away. For comparison, Earth's moon is nearly 400,000 kilometers from us. Their similar size results in a unique form of tidal locking. Not only does one side of Charon always face Pluto, but one side of Pluto always faces Charon. If you stood on the far side of Pluto, you would never see its moon, while on the near side, Charon would remain fixed in the sky. Because Charon is so large, the 2 bodies don't orbit each other in the usual way. Instead, they both orbit a point in empty space between them. This led some to speculate about a mini black hole, but it's simply gravity behaving in an unusual way. Observing Pluto and Charon's cosmic dance was just the beginning. As New Horizons closed in, it captured the first detailed images of Pluto's surface, revealing a world of surprising color and texture. Instead of a bland ball of ice, Pluto displays a rich palette of deep red, pale blue, white, yellow, and burnt orange. One of the first features to stand out was a vast, pale heart-shaped region. This heart is formed by low-lying plains of ice, and each side has its own distinct character. The side facing New Horizons is smooth and flat, an area called Planitia, roughly the size of Texas. What makes this region remarkable is the absence of asteroid impact craters, indicating that the surface is constantly changing and renewing itself. Along the upper edge of the heart, intricate patterns appear, created by glaciers flowing down from highland mountains into the frozen plains. This reveals that Pluto isn't made of ordinary water ice. At temperatures as low as -229 degrees Celsius, water ice would be too brittle to flow. Instead, the surface is largely composed of nitrogen ice. Earth's atmosphere is mostly nitrogen, and you might be familiar with liquid nitrogen, which freezes objects on contact. Now, imagine how cold it must be for nitrogen to freeze solid. That's Pluto. Zooming in on Planitia reveals lines in the ice that form polygonal shapes. These are caused by convection currents, heat rising from Pluto's core through the surface. This heat causes the ice to melt, but in the vacuum of space, liquids can't exist. So instead, the solid nitrogen undergoes sublimation, turning directly into gas. This gas rises, creating a thin atmosphere around Pluto. While not dense, this atmosphere forms layers of fog and extends high into space due to Pluto's weak gravity. Surface pressure on Pluto is about 1 million times weaker than on Earth, at least during New Horizons flyby, when Pluto was deep within the Kuiper Belt. However, Pluto's elliptical orbit sometimes brings it closer to the Sun. During those periods, sublimation increases and Pluto's atmosphere could grow to 1/4 the density of Earth's, with surface pressure 3 times that of Mars. This might even allow liquid nitrogen to form on the surface. P. Lovecraft's cosmic horror stories, though its official name is Belen Regio. What causes this vivid color? The leading theory points to tholins, organic compounds formed when solar radiation interacts with methane and carbon dioxide in Pluto's atmosphere. Once irradiated, these molecules clump together, turn red, and fall to the surface like radioactive snow. Traces of this red material are scattered across Pluto, illustrating the flow of ice, gas, and possibly liquid that carries tholins across the landscape. A less visible but equally fascinating feature is Pluto's giant ice volcano, Right Mons. This volcano rises about 5 kilometers high and spans 150 kilometers wide, erupting with a slushy mixture of water and methane. It's not the only cryovolcano on Pluto, but it is the largest. We don't know how often these eruptions occur, but the surface shows very few impact craters, indicating that volcanic activity refreshes the area relatively often, at least on a cosmic timescale, perhaps every few million years. But where does this slush come from? This is where Pluto becomes even more mysterious. Contrary to the old idea of a simple ice ball, evidence from New Horizons suggests Pluto has a hot core, with a thick layer of liquid water beneath the surface. This composition is similar to what we expect inside icy moons like Jupiter's Europa or Saturn's Titan. However, while those moons are heated by gravitational forces from their host planets, the source of Pluto's internal heat remains unexplained. In the solar system's early days, everything was hot and chaotic, but smaller objects usually cooled down faster. Pluto, being small and located in an extremely cold region, somehow retains significant internal warmth. Charon may hold clues to Pluto's strangeness. Their similar sizes make it unlikely that Charon was simply captured by Pluto's gravity. They likely collided in the distant past, and instead of breaking apart or merging, they became locked in this gravitational dance. The energy from that collision, combined with their mutual gravitational pull, may have injected new energy into Pluto, sustaining its internal heat. Interestingly, Pluto's heart-shaped feature lies on the side opposite Charon, which is probably not a coincidence. Charon also shows similar red tholin deposits, probably from ice volcano eruptions on Pluto violent enough to spray material into space, where it was eventually captured by Charon and accumulated on its north pole. Sadly, the images we have today will likely be the last close-up photographs of Pluto in our lifetimes. NASA has shifted its focus to more familiar destinations like Titan, Europa, Venus, and Mars. There isn't even a preliminary plan for a New Horizons 2, but the original probe continues its incredible journey. After its brief encounter with Pluto, it sailed onward, deeper into the Kuiper Belt. Remember, Pluto is just the brightest object out there, not necessarily the largest or the strangest. New Horizons is now exploring uncharted territory, uncovering new wonders, but that's a story for another time. If you enjoyed this journey to the edges of our solar system, make sure to subscribe for more explorations into space's greatest mysteries. Don't forget to like this video and share it with fellow astronomy enthusiasts. Your support helps bring more cosmic adventures to light.